start my recording and bring up this. Let's start with number 1. Now, probably the easiest thing for me to do is write it like this. You can see that okay?
Yeah.
Okay. And now, in algebra, you can always add any two equations. In other words, if I said a plus b equals 5 and x plus y equals 7, then I can add or subtract these two equations. In other words, I could add them and you get a plus b plus x plus y equals 5 plus 7. I can also subtract them at any point. You can always do that with equations. In other words, I could say a plus b minus the quantity x plus y must be equal to 5 minus 7. So you can always do those two things with equations. Okay? Now, what we have here is a system of equations where we have two variables. As long as you have the same number of equations as you have variables, you can solve it. If I told you that x plus y was equal to 10, that is one equation and two variables. I cannot solve that.
Yeah.
In other words, there's an infinite number of solutions. X could be 1, y could be 9, x could be 2, y could be 8. And then if you include negative numbers, x could be minus 2, y would be 12. So if I have only one equation and two variables, I cannot solve it and come up with an answer for x or y. But if I have two equations and two variables, I can do it. There's two ways to do it. One is called substitution. The other is called elimination. Does any of this sound familiar? Have you been taught this?
A little bit.
Okay.
And started teaching some.
Okay. Well, elimination is actually easier. Substitution would be used if one of the equations looked like this, the top equation. But let's say the other equation looked like this. In other words, if one of the two equations is already solved for one of the variables, like the second one is, I know what y is, then I can go back and I can take that and I can substitute it into the first equation, and I can say 2x plus 3, and instead of writing y, I'm going to write 3x minus 2. That's equal to 16. Well, now that gives me only one equation and one unknown. I know how to solve that. Let's make sure you do. In other words, we want to start at the beginning with you. I'm not real fond of where we're starting here. This is kind of the middle of algebra. But I'll get an idea on whether or not you know how to solve single equations with one variable by doing this problem right here. So what's the next step here?
Let me write this. This is just me.
Now, let me tell you, you're going to be able to watch these recordings. So you might want to not write stuff down unless you need paper to solve it. That's fine. You should have a pencil and paper in front of you. But in terms of making notes, I wouldn't worry about doing that at this level.
Yeah, no, I'm just...
Okay. All right. So read me the next line and tell me what the next step is.
See, this is just 3.
Okay. So what's the next line? It's 2x
2x plus what, 9?
X.
And then negative, or minus 6.
It's minus 6 because I'm distributing the plus 3 to the minus 2.
Yeah.
That's minus 6, okay? Just one more reminder of why it's so important to be good at your arithmetic skills, because in order to solve an equation like this, you have to make like 5 or 6 different single-digit operations. And what's that equal to?
16.
Okay, now what's the next step?
Do you add x and the 9?
Yeah, the next step is called combine the variables and put your variables on one side of the equation, your numbers on another. So first of all, how many x's do we have?
We have 2x, so it's going to...
What's 2x plus 9x?
Oh, that's 11x.
Okay. So now we have this. And now let's get rid of that 6 because that's not a variable. So we want to move our numbers to the right side and leave our variables on the left side.
So it's 11 equals 16 minus...
Remember, you're always going to do the opposite. Let's talk about this for a moment. If I want to get rid of that negative 6, I know the way they teach it in school is to do this. Right?
Yeah.
Well, why write that? It always results in the same thing, which is to get rid of the negative 6 on the left side. Okay? So, if it's helpful to you, write it. But the way I like to think about it is if I want to move this negative 6 to the other side of the equation, I just do it and change its sign. So that gets rid of it the moment I do that. As long as it's adding or subtracting, you can do that. You can just move it to the other side of the equation and change the sign on it. So now we have 11x equals what?
6. Oh, wait, no, I gotta add. Sorry. It's 20.
Okay. Now what's the final step of solving this equation?
Add next, or 11.
Divide by 11. In other words, right now the 11 is multiplying the x. So you always have to do the opposite. In other words, up here we were subtracting 6. So to get rid of it, we had to add 6. Well, we're multiplying the x by 11. To get rid of it, we have to divide by 11. And again, normally I would not write that on the left because I know that the whole reason I'm dividing by 11 is to get x.
Yeah.
Okay? So I usually skip that step and just write that x is 22 divided by 11 or 2. Okay? Now, how much time do we have to prepare before you have to go in front of a teacher again?
I'm not, a couple of months.
All right, so we're going to definitely have 8 sessions, 8 half-hour sessions, or 4 hours worth of tutoring?
Yeah, definitely.
All right. Let me change our curriculum here a little bit. If you don't mind, if your mom doesn't mind, I'd like to start. I have my own algebra book, which tends to start more at the beginning.
All right.
Okay? Which I think we need to probably do. We'll see. If you whiz through this, then we won't need to start there. But let's just start with some of these simple things here. I want you to simplify this. Here, let me even get rid of what I have in the background. Hold on. All right. I'm just going to write the problem here and ask you to simplify that.
All right.
In other words, I don't even need the equal sign here.
Yeah.
Just simplify that expression. How many x's do we have?
We have 9.
Okay, so we can combine like terms. What we can't do is combine non-like terms.
Yeah,
In other words, if I have a 2x plus 3y, that is not 5 anything. Okay, that is 2x plus 3y. That's what the answer would be. So we can only combine terms that are like. How many y's do we have? Always include the sign.
Oh, so all right, so
Add those two together. Think a plus plus. What is plus 4 minus 6? Or what is 4 minus 6?
4 minus 6, negative 2.
Negative 2. The variable is not the difficulty here. In other words, the variable just gets carried along. Okay, so that's the simplification of that expression. Is all we've done is combined like terms. That's a like term with that. That's a like term with that. And we've had to include the sign. Now, in the first case, there was an implied plus sign in front of that 2x. Okay?
Yes.
All right, let's try a different one. What's that equal to? Multiply the two numbers. In other words, we're going to distribute that, right? We got to multiply it by that, and then we got to multiply it by that, and we got to add the two things together. So what's 2x times 4y?
It wouldn't be their x.
That's what it is right there. In other words, it's just put all four things next to one another and then multiply the two numbers. So you end up with 8xy. Now, how about 2x times 3x?
That's 6x.
6x squared. In other words, I still have to multiply the x times the x, so I could write it like that. But when I have x times x, that's x squared, and it's more efficient to write it like this. Okay?
Yeah.
Now, let's talk about that for a moment. There's a difference between this and this. In the first case, in fact, let me change the number here, just so I don't confuse you with my numbers. In this case here, the 2 does not operate on the 3 because it is not in parentheses. So this would be equal to 3x squared. What's this one equal to?
That's 9.
Yeah, in other words, I have to square both the 3 and the x. So I end up with 9x squared. Having a lot of problem with the audio on your end. I'm wondering if it would be worth me calling back on this phone just to get a different line.
Okay.
Can we do that?
Yes.
Let's see if that helps. Hold on a minute. I know we don't have much time left, but let's see if we can fix this problem here.
Okay.
I'm going to end the call, and then I'm going to call back again on this same line.
number you are calling does not accept unidentified calls. If you are a solicitor, please hang up now. Otherwise, please enter the 10-digit telephone number you are calling. The number you are calling does not accept unidentified calls. If you are a solicitor, please hang up now. Otherwise, please enter the 10-digit telephone number you are calling from.
Yeah, I'm here.
Yeah, okay, good. That might be a little bit better. Sounds better right off the get-go. All right, here, let's get back to what we were doing here. Can you hear me okay, Chris?
Yeah.
Okay. All right. Let's do this problem here. Simplify this for me, if you would.
Okay.
And if you can do this kind of thinking out loud, in other words, as you do it, talk out loud, and I'll write it step by step. I don't really want you to do the whole thing and then just give me a final answer. It's helpful to me if I can see the process that you're using.
So I have to do the x.
What's x times x squared?
X cubed.
You add the exponents, and there's a 1 right there. So it's x cubed. What's the next term?
Plus x squared.
Correct. And the next term?
Plus 1x.
Plus what?
1x.
Or just x. Okay.
Yeah.
And we still have this minus x squared. So now simplify it. How many x cubes do we have?
1.
How many x squareds do we have?
2.
Combine them.
4.
If I have a plus x squared and a minus x squared, what do I have?
Just an x.
Got nothing.
Cubed.
You got nothing. In other words, this is one apple minus another apple. If I start with one apple and I subtract another apple, I got no apples. So the x squared terms cancel. So I can cancel that with that. And how many x's do I have?
Now 4 x's.
No, just one x. Remember one thing here, and that is that, hold on, just a second. You can only add and subtract like things. When I get x cubed plus x, that's not x to the 4th. If I was multiplying, it would be. In other words, if I had x cubed times x, that would be x to the 4th. But when I'm adding them, I can't really add them. They're different things. They're not the same thing. This is an apple, this is a pear. So that's my final answer. Okay? And that's why you see polynomials written like this. X squared plus x minus 1. And that's the final thing you see because none of those can be combined together. They can be multiplied and divided, but they can't be added or subtracted.
Yeah, I get it.
Always remember that addition and subtraction is harder than multiplication, particularly when it comes to variables in algebra. So, all right, it's 11:30, so that's probably a good stopping point. I've discovered a lot as to where we should begin or where we should go the next time.
Mm-hmm.
I think we're on the right track towards giving you a good foundation for algebra. And the most important part that I'm happy to see is how good you are on A+ math.
Yeah, that's just...
The one thing that's impossible to do, it's impossible to be good at algebra and geometry unless you have a good foundation in arithmetic. It just is. You cannot get by with a calculator. There's too many little calculations you have to do always. And you need to be able to do those in your head. So getting good at single-digit arithmetic is really the foundation for building your algebra skills. And I'm confident that we'll get you there, as long as you keep working on the side. I can't really do much for drilling you in the flashcards. I mean, we could spend every half hour doing that, but that's not the best usage of our time.
Yeah.
But it sounds like you're doing that on your own, at least for now. But just get so you can do it accurate and fast. That's the two key things. You can even start trying to use the timer they have on that page and see what happened. I've never actually used that timer. But
I did
the
other day.
Yeah.
Just counts how long it takes for that one problem.
Okay. All right. Well, obviously speed is important, because if there's too much time, then you actually are better off using a calculator to do it. The problem is that once you get dependent on the calculator, everyone loses those internal skills. So you want to be real careful as to how dependent you get on a calculator.
Yeah.
All right. Let's see. Did you guys think about another day and time that maybe you would like to do a session? I can go ahead and put it down on my calendar here while we're on the phone, if it makes it easier.
Mm-hmm.
Let's do
So
that.
me and my grandma were talking either Friday or Monday.
Let's do Friday. Friday's a good day for me. That sounds a little choppy just because I'm pulling up the browser again here. Does Friday at 11 work?
Yeah.
You want to do regular on Tuesday and Friday at 11?
Sure, that sounds...
Let's do that. Let me put you down here, and that way you don't have to worry about going in and doing it. And then if you need to change that, that's fine. You can text me, email me, whatever you want.
All right.
But what we'll do for at least the first part of this summer is, now, the next time, this Friday, I won't call you. I will text you the meeting ID number to your personal phone.
All right.
Now, between now and Friday, you may want to consider picking up a microphone for that computer. They don't cost...
Yeah, she just left buy one right now.
Cool. Yeah, they're not expensive, and it'll make the audio a little easier, I think, if we are going through the GoToMeeting software as opposed to me calling you on my Google phone.
Yeah.
Okay. Chris, I'll talk to you on Friday, the 26th. That's this Friday at 11.
All right.
All right. Have a good one. Bye-bye.
Thank you.